Okay, when dealing with different triangle types, again, reminder that scalene triangles have no congruent sides. Isosceles, again, I think about the word eyes. Like you have two eyes, an isosceles triangle has two congruent sides. Then you have which means equal, equilateral, meaning equal sides, equal side triangles, and we'll show you how to deal with each of these. First off, in an isosceles triangle, you have what's called the vertex angle. That's the top angle. Then you have your two base angles. The biggest thing that you need to remember about actually both of these types of triangles is the symmetry. That if I were to draw a line of symmetry, it would actually be the altitude of that triangle. If you were to draw a line from the top straight down, it would cut it into two perfectly symmetrical sides, meaning that the angles at the bottom would be the same size. And then to find that vertex angle, all you'd have to do is subtract those from 180. For example, if I were to tell you that one of the base angles measures 50 degrees, and this is definitely not drawn to scale, because of the triangle symmetry, the other vertex angle will also be 50 degrees. And since the three angles in a triangle add up to 180, that would make this top angle 80 degrees. And again, all that because of that symmetry that we demonstrated with that altitude a while ago. So if the whole angle at the top is 80, that would also, this altitude would cut that into 240s. Equilateral triangles actually have three lines of symmetry. You could divide it any different way, but if we were to divide it like this, first thing we notice is that all the angles have to add up to 180, and since all the sides are the same, all the angles are the same. So therefore, each of the base angles here are 60. The vertex angle up here is also 60, which makes that split into 30-30. So now all of a sudden you have two 30, 60, 90 right triangles. Looking at a couple of problems. This is what you've got going on, is if we know that one side is 10, because of the symmetry, the other side is going to be 10. However, we don't know any of the angles, but we can use some of our basic trigonometry. We can draw that line of symmetry. And since we know it is symmetrical, since the whole bottom is equal to 6, that means that one side is 3, the other side is 3. If we're looking for an angle, now we can again use basic SOHCAHTOA. Let me write what everything stands for, SOH, and TOA. Since we are given, here's my angle, since we are given the hypotenuse, and we're given the adjacent side, we can actually use cosine to find this missing angle. We know that the cosine of an angle is always equal to adjacent over hypotenuse. Whenever we mark that out and do the inverse cosine of 3/10, we actually find out that this angle is going to be a 72.5 degree angle. Because of the symmetry, we know the other angle is also going to be a 72.5 degrees. Let me erase that line of symmetry. If we were to add those two angles together, that gives me 145 degrees. When I subtract that from 180, that gives me that my top angle is 35. And again, if you would like to draw that line of symmetry again, actually I'm going to. We can draw that line of symmetry again. We know that that cuts this into two angles that would actually be 17.5 degrees apiece. Something else that we can do, since we're given two sides of this triangle, anytime you're given two sides and you're asked to find a third side, you could use Pythagorean theorem, because we know that in a right triangle, that a squared plus b squared equals c squared. Now be cautious, because this is actually the value of c. So we know that 3 squared plus b squared is equal to 10 squared. 9 plus b squared equals 100. Move the 9 over by doing subtraction. That's going to be b squared is 91. So this height or altitude of this isosceles triangle would equal the square root of 91, which is somewhere around 9.5. Anytime we're working with equilateral triangles, again, we're doing the same thing. We know that if one side is 12, the other side is also 12, and it has lots of symmetry going on here. So that means actually all three sides would be 12. Soon as we draw this altitude or height, which is also its line of symmetry, that's going to cut the bottom into a 6 and a 6. Since all angles was equal to 60 degrees, when we drew that line of symmetry, it actually split this into two 30s, which again created a 30, 60, 90 right triangle. And just a reminder that in a 30, 60, 90, the short sides always cross from the 30. So the short side here is 6. The hypotenuse will always be double that measure. And then the third and missing leg, or third side, which is the longer of the two legs, is always equal to the short side times the square root of 3. So that would actually give you the altitude.